Hey guys, so today we're going to talk about everyone's favorite thing, word problems. So there is only one type of word problem that you guys need to know for our chapter on radicals, and it involves the Pythagorean theorem. So that's what we're going to talk about today. I'm going to walk you through one word problem example, and you're going to see how this works and how to solve these types of problems. We're going to use the same map that we use for every chapter: label, translate, solve, and answer. Okay, so let's walk through those 4 steps using our word problem. So just like with every word problem that we've seen so far this year, we've used the same map, right? And we're going to continue to use that same map of label, translate, solve, and answer. Okay, only for these word problems in our radical unit, we're going to use the Pythagorean theorem during the translation and solving steps. And what does the Pythagorean theorem say? It says that when you have a right triangle, a squared plus b squared equals c squared, where c is the length of the hypotenuse, and a and b are the length of each side. Okay, so let's read our problem. A right triangle has a hypotenuse of 13 meters. One leg is 7 meters longer than the other. Find the perimeter of the right triangle. So you guys know I always say read a problem 3 times. The first time, just read it. The second time, start circling or highlighting important information. So let's do that. A right triangle has a hypotenuse of 13 meters. That's important. Okay, 13 meters. One leg is 7 meters longer than the other. So I'm going to highlight that. I think that's pretty important. Find the perimeter. That word pops right out at me, of the right triangle. All right. Now read it a third time, and then the third time really zoom in on what the question is asking you. So let's read it a third time. A right triangle, I'm starting to picture this in my head, has a hypotenuse of 13 meters. One leg is 7 meters longer than the other. Find the perimeter of the right triangle. Now you guys, that's important, okay? Because we're being asked to find the perimeter. We're not being asked to find the lengths of the legs, though we are going to have to find those. We're being asked to find the perimeter of the right triangle. So at the end of this problem, my answer better be the perimeter, okay? It's so important to really understand what the question is asking you, okay? Because sometimes we read these problems and we think about, oh, I've got to solve for this, but we don't actually think about what we're being asked to find. Okay, we are being asked to find the perimeter. And it's important to then define for yourself, what is perimeter? Oh yes, the perimeter is the sum of all sides. So when I'm looking at a triangle, it's the sum of side A plus side B plus side C, okay? A triangle has 3 sides. We need to add the length of those sides together in order to get the perimeter, okay? A perimeter is a measurement. It is a measurement of how long of the outside, how long is the outside of a shape, of an object, of something, of a space, okay? So when we're measuring the perimeter of a triangle, we are adding together the length of each of its sides, okay? So that's important for us to understand. When you're doing these word problems in this chapter, you're going to want to sketch out your triangle. That's going to be really helpful for you, which is why I've sketched it here. So we're going to do steps 1 and steps 2 on this slide together. They sort of go together with our sketch here. So step 1 is to always label a variable. And what is a variable? An unknown. It's what you don't know, okay? And so it's really helpful to think about what you do know in order to figure out what you don't know, all right? What do we know in this problem? Well, we know the length of the hypotenuse. The length of the hypotenuse is 13 meters. It told us that right in the problem, okay? So that means we know the length of side C. But we don't know is the length of side A or side B, okay? So we don't know these lengths yet. But we do know that one leg is 7 meters longer than the other. And remember, when you label a variable, you only want one. You only want to be solving for one thing. So it's really nice that we can actually write the length of one leg in terms of the other. So let's call the length of our first leg, let's just call it A, okay? It's right here, let's just call it A. Well, if we know that one leg is 7 meters longer than the other, then that means that leg B must be A plus 7, right? It's the length of A plus 7 more. It's 7 meters longer than the other. Okay, so that leaves us with our variable named A, all right? So we have A, one leg, which we're calling A. Leg B, we're calling A plus 7, and we know that the hypotenuse is 13 meters, okay? So now we can actually use the Pythagorean theorem to write a really nice translation for us so that we're going to use to solve, okay? So we know that the Pythagorean theorem tells us a squared plus b squared plus c, or excuse me, a squared plus b squared is equal to c squared when we have a right triangle, right? The sum of the legs squared is equal to the hypotenuse squared, okay? So the first leg squared plus second leg squared equals the hypotenuse squared, all right? Well, for us, that means that, well, our first leg we called a, so a squared. Our second leg b, we know is a plus 7. So we have a plus 7 squared. Quantity a plus 7 squared is going to be equal to 13 squared, okay? So now we've translated and gotten a lovely formula. A squared plus quantity a plus 7 squared equals 13 squared that we can use to solve. So let's do that on our next slide. Okay, so now we can move right into the solve step. We're going to solve using algebra. So as we discovered on the previous slide, right, we were able to get this lovely equation, a squared plus quantity a plus 7 squared equals 13 squared, right? We got that from the Pythagorean theorem, which says a squared plus b squared equals c squared. Here, our first leg a, we just named a. Our second leg we knew was 7 meters longer than our first, so we named leg b a plus 7, and our hypotenuse we knew was 13 meters in length. So a squared plus b squared equals c squared, right? That's where that came from. All right, so now let's solve this. Let's actually solve it out. So we have a squared. Here we have a quantity being squared, you guys, so we have to be really careful. This is not a squared plus 7 squared. No, no, no. This is the quantity a plus 7 squared, which means it's 2 copies of quantity a plus 7 being multiplied together. Okay, that's really important. Don't make that mistake. All right, equals 13 squared. So our a squared is going to stay the same. We have to FOIL out a plus 7 times a plus 7, which gives us a squared plus 14a, oops, plus 49, okay, when we FOIL that out, and 13 squared is 169. So now let's combine our like terms. We can combine our a squareds to give us 2a squared, right? We have a squared plus a squared, so that gives us 2a squared. All right, plus 14a plus 49 equals 169. And just like with any other solve with a polynomial, right, we want to get everything on one side, 0 on the other side, so that we can factor and use the principle of zero products to solve this. So if we need to move this 169, whoops, we need to move the 169 over to the other side so that we can factor and solve. And how are we going to do that, you guys? We're going to subtract 169, right, from both sides. So let's do that. So that will get rid of the 169 on that side. It will zero it out, which leaves us with 2a squared plus 14a minus 120 equals 0. Okay, so now we can factor and solve. There is a GCF here, you guys. Remember, when you're factoring, the first thing you should ask yourself is there a GCF? There is. It's 2. We can pull a 2 out of each of these terms. Okay, so let's do that. Let's pull our 2 out. That leaves us with a squared plus 7a minus 60 equals 0. We're going to use the AC method to solve this. So we're looking for factors of negative 60 that add to positive 7, okay? So that's going to leave us with 2 times a plus 12, it's a minus 5, right? Those factors were 12 and negative 5 equals 0. And so by the principle of zero products, we know that either a plus 12 equals 0 or a minus 5 equals 0. If a plus 12 equals 0, then a would have to be negative 12. And if a minus 5 equals 0, then a would have to be 5. Now, this is where you really need to stop and think about your answer, you guys, okay? We are going to have to interpret this answer in just a second. So let's move on to our next slide, and then we'll really talk about and interpret this answer, okay? The important thing to remember is that we solved and got a equals -12 and a equals 5. Okay, so now we can move into our last step, which is, of course, to answer in English with units. So if you remember from our previous slide, we solved for a, and we got that a equaled -12 or 5. And -12 what and 5 what? Meters. This question was asked using the unit meters. So we need to remember to use that in our interpretation. So you guys, right away, that should disturb you. One of these answers should disturb you, okay? We cannot have a negative length. So right off the bat, we can go, oh my goodness, -12 meters, that doesn't even make sense. -12 can't possibly be the answer. So our A, the length of our side A over here, must be 5 meters, okay? You can get rid of negative measurements right off the bat, all right? So if our first leg that we called A is 5 meters, well then B, our second leg, must be 5 plus 7, which is 12 meters, okay? And we should check just to make sure that checks out, okay? We should use the Pythagorean theorem to just make sure that checks out. Remember, the Pythagorean theorem says a squared plus b squared equals c squared. Now we can plug in some numbers and just make sure that that's true. So that says that 5, if we plug in 5 for A and 12 for B, and of course 13 for C, okay, this should check out. 5 squared plus 12 squared should equal 13 squared. And in fact, it does, okay, you guys? So 5 squared is 25, 12 squared is 144, and 13 squared is 169, okay? And 25 plus 144 is 169. So that does check out, all right? So we did our math correctly. Now, remember how I made such a big deal out of really making you focus on what the question was asking? The question wasn't just asking us to solve for the lengths of each side, you guys. It asked us to find the perimeter of the right triangle. Okay, and yes, we needed the lengths of each side to solve for the perimeter, but now we have to actually find it. So remember, the perimeter is the sum of all sides. It's the measurement of the outside of an object, a shape. So we need A plus B plus C. We need the length of leg A plus the length of leg B plus the length of leg C. So here, our first leg was 12 meters. Our second leg was, our first leg was 5 meters. Okay, so leg A was 5 meters. Our second leg, which was B, which wound up being A plus 7, right? That was 12 meters. And then, of course, leg C, the hypotenuse, was 13 meters. Oh, I forgot my little meters over here. So 5 meters plus 12 meters plus 13 meters. What does that equal, you guys? 5 plus 12 is 17. 17 plus 13 is 30. So the perimeter of this triangle is 30 meters. So now we have indeed answered the question, okay? So it's really important to make sure that you answer the question and interpret it to make sure it makes sense. And here it does, all right? So remember, label, translate, solve, and answer. And for these problems in the radical unit, you are going to be using the Pythagorean theorem to solve them, all right? That's to translate and solve. That's really important. All right, you guys, so good luck. Have fun. Let me know if you have any questions. All right, bye.